Chapter 3, Video 6. This should wrap up Chapter 3. We're going to go through and talk about the electrocardiographic truths and just several things that you guys should know about the EKG strips. So, the electrocardiographic truths. Positive QRS complexes are written by impulses traveling toward the positive electrode. So this positive QRS complex means that it's pointing upward on the EKG. An electrical impulse traveling toward that positive electrode produces a positive QRS. The negative QRS from impulses traveling away from the positive pole, okay? So with negative QRSs, they're traveling away. Impulses are traveling away from the positive or toward a negative. The electrode writes a negative or downward deflection of the QRS on the EKG strip. And now we're going to talk about the isoelectric QRS. The isoelectric QRS are from impulses traveling perpendicular to the positive electrodes. So basically these impulses are traveling at a right angle to the positive electrode, and it writes an isoelectric complex. That's one that is as much positive as it is negative, okay? So flipping over to the next slide, you can kind of tell here which ones are which. So this would be the negative. Then if it's traveling toward the negative, you're going to see that downward deflection. If it's traveling toward the positive, you're going to see that positive deflection, that upward deflection. And then this is the isoelectric. It's as much downward as it is upward. So that's the one that's traveling at that right angle. The normal QRS deflection leads 1, 2, 3, AVL, AVF, should all be positive QRS complexes. The AVR complex should be negative, and the normal vector of the heart's current is top to bottom and right to left. So let's talk about the vector. The vector, that's the arrow depicting the general direction of current flow. Current normally starts in the sinus node in the right atrium, and it terminates in the left ventricle. The current of the heart normally starts in the sinus node, which is in the top right atrium. Again, it starts in the top right atrium. It travels down through the heart, and it ends in the left ventricle. Both ventricles are innervated simultaneously for the most part. The left ventricle finishes depolarizing because it's a larger muscle. So when we're talking about the normal vector, this represents what a normal heart current looks like. So it starts in this area of the heart and it travels downward. Again, this is a normal QRS deflection and leads 1, 2, 3, AVL and AVF. And then we can go on down and look at what it is in the AVR. Normal QRS deflections in the precordial leads, we have V1, V3, and V5, or the MCL. V1, or the MCL on continuous monitoring. V2 should be negative. V3 and V4 should be about half up and half down. V5 should be positive. And then the normal QRS deflections, again, in the precordial leads. In V1, the septal and the right ventricular depolarization send the current toward that positive electrode, resulting in that positive deflection. V1 should have a small R wave and a deep S wave. This complex is mostly negative because of the heart's current is traveling toward that left ventricle. So I'm going to go over. Let me scroll down. This shows you normal in V1. This is what a normal 12-lead EKG looks like. Make this slide your friend because in leads 1, 2, and 3, we have a positive deflection. AVR is negative. AVL is positive. AVF is positive. V1 is negative. V2 is isoelectric. V3 is isoelectric, and V4. These are isoelectric because there's as much going upward as it is downward. 5 and 6 are positive. So you need to learn this slide. Know this, know this, know this. If you have any questions, please let me know.